Direct current. A battery supplies electrical energy to a circuit. Chemical reactions inside the battery convert chemical energy into electrical energy. This energy is carried around the circuit by a flow of charged particles called an electric current. It is convention to assume that the charge carried is positive. The current flows from the positive to the negative terminal of the battery. We call this type of current direct current, as it flows continually in one direction. Notice the voltage across the lamp and the current delivered to the lamp are constant and do not change direction. We can reverse the direction of the direct current through the lamp by changing over the battery connections. The size of the direct current is still the same, and it flows continually in the same direction through the lamp. The oscilloscope simply tells us that this direction has been reversed by reversing the battery. It is still direct current. Alternating current. In the UK, the mains electricity supply is an alternating current, AC supply. In an alternating current, the current is continually changing direction. In the UK, the frequency of the mains supply is 50 Hz. This means that the current changes direction 50 times each second. If an oscilloscope is connected across the lamp in the circuit shown, the voltage across the lamp can be seen to be changing direction. The voltage delivered to the lamp by the mains supply is continually changing both in size and direction. Electrical cables are used to carry the electrical energy delivered to the home to each electrical appliance. The cables connected to most appliances contain 3 copper conductors. Each conductor is covered with a layer of flexible plastic. This plastic is a good electrical insulator and prevents the copper conductors from touching and causing a short circuit. Copper is used for the wire cores as it is a good electrical conductor. The 3 wires are held together by covering them with a flexible plastic, increasing the insulation. These wires are called live, neutral and earth. Most electrical appliances in the UK are connected to the mains supply by a 3-pin plug. The plug has 3 pins made of brass. Brass is used because it is a good electrical conductor. The brown wire. The brown wire is connected to the live terminal, which, in turn, is connected to the fuse. The blue wire. The blue wire is connected to the neutral terminal. The yellow and green wire. The yellow and green wire is connected to the earth terminal at the top of the plug. The cable grip. The cable is held firmly in position by a cable grip. A fuse contains a short, thin piece of wire made from a metal alloy with a low melting point. A fuse must always be connected in the live wire of an electrical circuit. Each fuse has a current rating. If the current in the circuit is below this value, the appliance will work continually. If the current in the live wire should become too large, the fuse becomes too hot and melts. This breaks the circuit and reduces the risk of fire. The size of the current taken by an electrical appliance when it is working normally depends upon its power rating. The current taken can be calculated by using the equation. Current equals power divided by voltage. A 2 kilowatt electric fire operating at a mains voltage of 240 volts will draw a current of 8.3 amps. The fuse chosen must be of a higher current rating. It should also be the next closest current rating available. 2 kilowatts divided by 240 volts equals 8.3 amps. Nearest fuse would be 10 amps. All electrical appliances with metal cases must be fitted with an earth wire. An earth wire is a copper wire covered in flexible plastic insulation and coloured yellow and green. The earth pin is connected to the metal casing of the appliance by this wire. If the device is working correctly, current flows through the live and neutral wires alone, completing the circuit. If the insulation supporting the heating element should break down, the live wire may touch the case. The whole case would become live, and a large current would now flow through the earth and live wires. This would melt the fuse, breaking the circuit and disconnecting the current. If the earth wire was not in place, the whole case would become live. Anyone touching the case would experience a serious, if not fatal, electric shock. Most modern houses have their mains electrical sockets protected by miniature circuit breakers, MCBs. These perform the same function as a fuse but are faster acting. providing better protection. The added advantage of MCBs is that they can be reset when they have tripped out to protect the circuit. Residual current or earth leakage circuit breakers operate by detecting a difference in currents between the live and neutral wires. Residual current circuit breakers are often used to provide increased protection when using lawnmowers, chainsaws and hedge cutters. These devices could accidentally cut through the mains cable, leading to an increased risk of electrocution. If such an accident should occur, the current in the neutral wire will fall and the live supply will be disconnected. Some electrical devices do not require an earth wire. This is because the outer casing of these devices are made of plastic, which is an electrical insulator. This means that the outer casing can never become live. If the live wire should become loose and touch the casing will not become live. The outer plastic casing is an excellent electrical insulator. The kilowatt hour. The electrical energy consumed by a device depends upon its power rating and the time for which it is working. The energy used by an electrical device can be calculated from the equation. Energy equals power multiplied by time. A 1000 watt fan heater used for 1 hour would therefore consume 3,600,000 joules of electrical energy. This shows us how small 1 joule of energy actually is. The joule as a unit is too small to measure domestic electrical energy consumption. Domestic energy consumption is measured in energy units or kilowatt hours. 1 unit of electrical energy is the energy used by a device of power 1 kilowatt in the time of 1 hour. In 1 hour, our 1 kilowatt fire will consume 1 unit of electrical energy. This 1 unit equals 1 kilowatt hour. This is equivalent to 3.6 million joules. The domestic consumer is charged for the number of units of electrical energy used in a certain time interval. Each household has an electricity meter that records the number of energy units consumed. The number of units used can then be obtained by subtracting the initial and current readings. Here, 1,090 units of energy have been consumed at a cost of 6.3 pence per unit. The total cost of the energy used is 1,090 units multiplied by 6.3 pence per unit. The cost of the energy used is £68.67.